Greetings, math fans. All right, so this is day one of chapter six, and the topic for really this whole chapter is called systems of equations. That's what it says here. Let's highlight this. It says, what is a system of equations? It's basically a system of equations is multiple equations. So it's really more than one equation. And what we're going to do is we're going to solve for a system of equations. So it's more than one equation, and you want to look for, we call these solutions. And that's what it even says. It says steps to test if a point is a solution to a system of equations. So it's more than one equation, and we're looking at intersections of lines. That's really what we're doing here, math fans, looking at the intersection of lines. So we're going to start off here, but it says steps to test if a point is a solution to the systems. Really, really, really easy. You basically plug in a point, plug in point to equations. Okay, and then when you do that, you basically test if the left side equals the right side. So we're going to plug in an x comma y into that equation. Okay, and that's what we're going to give. That's what we're given here. So let's look at number one. Basically, you're given two equations, and you're given your x is -3 and your y is 2. Okay, and you literally plug those x's and y's into the equation to see if for the first one it equals 8, and for the second one it equals 16, and that's all you do. Use your calculator, whatever you need to do, but you plug it in. So let's just do it. 4 times -3 plus 2 times 2, does that equal -8? That's the question. Well, let's figure it out. -12 plus 4 equals -8, and -12 plus 4 does equal -8. So that one's true. Now, in order for it to be a solution, it has to work in both equations. Okay, so let's plug that in. -2 times -3 plus 5 times 2, does that equal 16? Well, it's 6 plus 10 equals 16, and 16 does equal 16, so that's true. So since both of these are yes, we say check whether it is a solution. We say yes, it's a solution. Okay, that's it. If one of them doesn't work, obviously if both don't work, then it's wrong. It's not a solution. But even if one doesn't work, then it's not a solution. It has to work in both. It's really, really, really important, math fans. Okay, so let's try the next one here. It's 2 times 5 plus 7 times -2. Does that equal -4? So 10 minus 14 does equal -4. Yep, -14 or -4 equals -4. So it is true. Okay, plug in the next one. -4 times 5 minus a -2. Does that equal 8? Well, I can kind of see it's -20 plus 2, and so it's -18 does not equal 8. So it's false. So the answer to this question is not a solution. Okay? Pretty easy. Okay, so the next part here is graphically, what does it mean for a point to be a solution to a system of equations? So I kind of mentioned this before. When you're graphing a point or two lines, you want to see where the lines cross. Okay, that is basically what we're going to do. We're going to graph them really, really nicely, and we're going to see if they cross, where they cross, and that is your solution. Okay? It's really not difficult at all. Now, this one's really nice because I handed you two equations in slope-intercept form. Remember, it's got to be in this form in order to graph it. Right? M is your slope. B is your y-intercept. Okay, so like for the first one, you're going to graph 4 for the y-intercept. Now here's the deal. I am not going to just graph that and then use my slope. I'm actually going to graph several points because it's much easier if you graph several points to see where they intersect, the lines intersect. So do you agree with the slope is 1 over 1? So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and I'm going to go the other way too. Down 1 over 1, down 1 over 1, down 1 over 1. Sometimes it gets a little confusing because kids sometimes don't want to go down 1 to the left one, even though it's still positive. Because remember, a negative, if you go down 1 to the left one, it's the same thing as going up 1 over 1, because a negative over negative is a positive. Okay, but notice I didn't actually just plotted points there. Okay, now what I want to do is I want to let's do the next equation. Y equals negative x plus 2. So here it is 2, and negative means go down 1 to the right, so this is negative. Well, I really don't need to go any further that way. How about going this way? So if you see, it just intersected that line. Okay, so this, math fans, right here is your solution to this equation. Because I mean, technically, you're really supposed to graph it nicely here. Okay, but by plotting a bunch of points, it really helps to determine where things are intersecting. Okay, I was able to circle that in the green over there. So anyway, the solution to this problem is negative 1 comma 3. Negative 1 comma 3. Okay, that's all you're looking for. You're looking for that solution where the lines cross. Okay, it's really easy to test it too. Okay, if you guys have time at the end of a quiz or test, it's super easy to test this. Literally, you plug the negative 1, 3, just like we did right here, math fans. I asked you, check whether each ordered pair is a solution. This is exactly the same thing. So if I took that negative 1, 3 and I plugged it into, remember this is x and this is y, so be careful. If I plug it back into the first one, I get 3 equals negative 1 plus 4. So that's 3 equals 3. That one works. And the other one is 3 equals negative of a negative 1 plus 2. So 3 equals 1 because it cancels. So it's 1 plus 2 is 3, and that works. So that's just a double check. Okay? Alright, so it says how to find the solution to the system by graphing. So again, we talked about this already. You're going to graph both lines, and you're going to really plot lots of points. Okay, and then to find the intersection of the two lines. Okay, so let's practice here a little bit. It says graph the following equations, estimate a solution to the system, check your solution algebraically. Okay, so again, these are really easy. The slope is 3, y-intercept is 1. And this one, the slope is negative 1, the y-intercept is 5. Okay, so let's go ahead and plot that. Okay, so now I can graph it. My first equation, y equals 3x plus 1. So I'm going to plot a 1 right here, and up 3 over 1, up 3 over 1. I can go the other way, down 3 over 1, down 3 over 1. Okay, so again, I'm not going to graph the line. I'm going to plot the other equation now. So y equals negative x plus 5. So I'm going to start out here at 5, and negative x goes down 1. Oh, I found my intersection point already. So I can plot a few more points if I want, but there we go. That point right here, math fans, that's my solution. Okay, so if I fill in the line now, just to actually give you the graph. Okay, that's that one, and here is this equation, and then that green point that I circled right here, that was the solution. And so that is 1 comma 4 is the solution. Okay, and again, it's really easy to check it. You just literally plug the 1 comma 4 into these two equations just to make sure they work. And if they don't work, then you did something wrong. Okay? All right, with B, remember, you just got to be in terms of slope-intercept form, so you have to solve for B. So in this case here, you guys need to be good at this. So plus 4x, so 2y equals 4x plus 8 divided by 2. Y is equal to 2x plus 4. Okay, so that's your slope is 2. B is 4. I'm just going to put this over 1 because it helps us graph it. Okay, and the next one, I'm going to subtract 2x. And I get 2y equals negative 2x plus 2. Divide both sides by 2, so y equals negative x plus 1. So the slope is negative 1, you can say over 1, and the y-intercept is 1. Okay, and we just go ahead and plot that. So the first one, slope is 2, y-intercept is 4. So I'm going to go to 4, and then the slope is 2, so I'm going to go up 2 over 1. Up 2 over 1, I'm going to go the other way, down 2 to the left 1, down 2 to the left 1. Okay, and then my next one was slope is negative 1, y-intercept is 1. So here it is. And negative 1 means this way, but I'm going to go back up this way. Oh, there it is. That's my solution right there, math fans. I'm just going to circle it right away. That's it. Okay, so let's go ahead and graph this now. And the other line. See, if you didn't plot those points and your graphs are a little messy, it's really hard to tell what the solution is. So I already plotted those points. I know my solution is negative 1 comma 2. Okay, and again, you plug it back in and you'll see that it's right. Okay? Okay, last one on this page here. Same thing, math fans. I'm going to subtract 4x. And we get 2y equals negative 4x plus 8. Divide by 2. Y equals negative 2x plus 4. So slope is negative 2. B is 4. Okay, this one just need to add x. So you get y equals x plus 1. So slope is 1. Y-intercept is 1. Okay, so go ahead and plot this. So B is 4. And the slope is negative 2, so it's negative 2 over 1. So down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. You could have gone the other way, up 2 to the left 1. That's also negative. It just follows, it's the same path as the other ones. Okay? And let's do the next one. So slope is 1 and the y-intercept is 1. So here it is at 1. And here we go, up 1 over 1, right there. Got our solution. Circle it right here. And you know, if you want to plot a few more points, it's okay. But understand we already have our solution here. So this is the solution for this. And this is the graph. So the solution to this is 1 comma 2. Okay, again, you can plug it back in, but that's it. All right, so that's pretty easy. Again, you just have to be good at graphing. Hopefully you guys are good at graphing. So the last part of the lesson, math fans, is we got special types of equations. All right, and these special types of equations are, let's just graph them. Okay, so this first one is the slope is negative 2 and b is negative 4, and this is slope is negative 2 and b is 8. Alright, so if I go ahead and graph these, negative 4 is down here, and the slope is negative 2. So it's down 1 to the right, down 1 to the right. Let's go the other way, up 2 to the right, or up 2 to the left, up 2 to the left, No, it's following a straight line here. Okay? And then let's graph the other one, which is y equals 2x plus 8. So I'm going to graph 8 is right here. And then down 2 over 1. Down 2 over 1. The other ones are pretty nice. They were like touching each other, and it was an issue. What's going on here? Well, the deal is, math fans, they are not touching at all. There's that graph. A little messy, but it's okay. There's that graph. What? What the heck, man? So what are these lines? These lines, math fans, they are parallel. Okay? They are parallel lines. And you know they're parallel because, look at the slopes, guys. The slopes are the same. Okay? If the slopes are the same, that means you know they're parallel as long as these are different. Okay? The y-intercept. I mean, look at the y-intercept for these. The one was -4, the other one was 8. They kind of need to be different. If they're not different, that'll be our next case. Okay? Well, we'll talk about that in a little bit. But right now, these lines are parallel. So they will never cross. So they're parallel. So lines don't cross because they're parallel lines. And here's the deal. This is the final answer. These lines are for this system of equations, it is no solution. This is important. Okay, after you graph it, if the lines are parallel, which again you can tell by looking at the -2's, if the lines are parallel, there's no solution because the solution is where they cross and they don't cross. All right, so you got to look for that. That's why you got to be really careful when you solve. Okay, let's do this last one now, math fans. Okay, if I solve for x, I'm going to subtract, or y, I'm going to subtract 4x. So -8y equals -4x minus 16 divided by -8. Y is equal to -1/2 x plus 2. Okay, it's cool. Let's do this one. This one I just need to divide by 4. So y equals 2 over 4 is 1/2 x plus 2. So this is positive here. Sorry. Okay. So the slope for the first one is 1/2, and the y-intercept is 2. The slope for the second one is 1/2, and the slope is 2. What? Wait a second. If I graph that, y equals 1/2 x plus 2, I'm going to graph the first one up here at 2, and then I go, the slope is 1/2, so up 1 over 2, up 1 over 2, and then if I plot the other one, well, what's going to happen? Look what I have again. I have slope is 1/2, b is 2. Guys, I'm plotting the exact same line. It's right on top of it. So this is basically the same line. That is really important. I mean, obviously you know that because look at the slope and the y-intercept. They're the same. Of course it's the same line. So the question is, if it's the same line, where is the red line intersecting the green line? You can't really see it anymore. Or the blue line. Where are those two lines intersecting? Everywhere. Don't you guys agree? They're on top of each other. So the solution is, this is the solution, we say infinite solutions. Infinite solutions because it's hitting it everywhere. And that's how you know that. So if it's the same line, it's infinite solutions. If it's a parallel line, it's no solution. Otherwise, it's just like one of these other ones here where you graph it and you have one solution. Okay? So hopefully that's good, math fans. I'll tell you, if you need to review graphing, make sure you do that because you have to know how to graph. You can't pass algebra unless you know how to graph and solve for x. You just can't. Okay? That's it, math fans. Have an outstanding day. Adios. Goodbye.